Hello everyone, I'm Minh Nguyễn from Klagenfurt University. Welcome to my presentation about our paper entitled H2BR, an HTTP2-based retransmission technique to improve the QoE of adaptive video streaming. Our presentation is divided into 5 parts. First, I'm going to introduce motivation, then our contributions. The proposed method H2BR will be explained in the third part. The last 2 parts are evaluation and discussion as well as conclusions and future work. As you may know, many adaptive bitrate algorithms choose the lowest quality segments in the startup phase. The left figure illustrates this issue. In addition, there are quality switches because of throughput fluctuations in a streaming sessions as shown in the right figure. To tackle these problems, we introduce an extension component at the client to improve the quality of the first segments in the startup phase, as well as eliminate the downward switches in the video quality. Besides, a throughput measurement when handling concurrent segments is also proposed. In this paper, we focus on the server push, stream priority, and stream termination features of HTTP2. The server push allows multiple segments downloaded by one request that can save some RTT delay. The stream priority expresses how the client would prefer the server to allocate resources when managing concurrent streams. It allows the client to control the download time of concurrent segments. Finally, the stream termination is used to terminate segment requests immediately. The proposed retransmission technique is executed by an extension component, namely retransmission module. It gets the information from the H2BR algorithm, playout buffer, and throughput estimation. If there are any segments that need to be redownloaded, a retransmission request will be sent. This module determines the bitrate of retransmitted segments denoted by RR, the number of retransmitted segments KR, the index of their first segment J, the priority parameters of retransmission request PR, and next request PN. Here is the overview of the proposed retransmission technique. The process is described as follows. First, the proposed component checks the estimated throughput and the current buffer level. If they are not high enough, then no retransmission occurs. Otherwise, it scans the buffer to search for gaps, which are defined as lower quality segments compared to their attraction ones. And the proposed component groups all the same quality consecutive segments together. For example, here we have 4 segments in the buffer which are divided into 3 groups, and the gap is in the group G1. Afterwards, the component needs to find the parameters, which is J, RR, and KR, that satisfy these 4 conditions. First, the retransmitted throughput that needs to deliver retransmitted segments must be less than the estimated throughput so that the next segments can also be delivered. Second, the estimated buffer after downloading all the next and retransmitted segments must be higher than a threshold. Third, the retransmitted bitrate is between the bitrate range of attraction groups. For example, the new bitrate of the group G1 is between the quality level of group G0 to that of group 2. Finally, the number of retransmitted segments is no more than the number of segments in the group. So in this example, KR can be 1 or 2. If there is a set of these values, the H2BR will determine the priority parameters PR and PN based on this formula. This is to ensure that the retransmitted throughput are allocated to deliver the retransmitted segments. To avoid stalls, retransmitted segments will be terminated if the current buffer is less than a certain threshold or the remaining time for downloading retransmitted segments is less than a predefined threshold. Well, when the client downloads concurrently segments, the traditional throughput measurement, which equals the segment size divided by segment download time, only refers to the throughput allocated to one segment. So, to measure the whole available throughput capacity, we use this formula, which is the amount of data downloaded in two timestamps divided by the download period. In experiments, two machines, one server storing video content and one client are used. Both are built on ng HTTP2 library. Dominant tool is used to emulate a network trace. The video content is Big Buck Bunny with nearly 600 seconds. It is split into multiple segment duration from 1 second to 6 seconds. And this video is encoded into 20 versions with different resolution. We compared our method with the squad retransmission technique. Well, in the ABR algorithm, we use three algorithms. One throughput based, namely AGG, one buffer based BBA, and one hybrid SARA. In this paper, we considered the following metrics: the CDF of video quality expressed as the cumulative distribution function of quality versions of segments, average video quality, which is the average quality level from levels 0 to 19 play out on screen, average switch step determined by the average of quality decrease, and QoE, which is the overall quality score computed by mode 0 of the ITUT QoE model. Well, in terms of the experimental results, here is the CDF of the video quality when the segment duration is 4 seconds. We can see that the number of the lowest quality segments is smallest when the H2BR is deployed. In the left figure, for instance, the percentage of the lowest quality segments in H2BR is only 0.7%, whereas these figures for squad and no retransmission are more than 2.6%. In this case, as all of the lowest quality segments are downloaded at the beginning of the streaming session, H2BR is able to deal well with the aforementioned ABR algorithms issue in the startup phase. In terms of the average video quality, the figures show that our H2BR method provides the highest average video quality in the most cases when AGG and SARA ABR algorithms are implemented. Meanwhile, in regard to the BBA ABR, this figure for our proposed method is slightly less than that of no retransmission, but still higher than that of squat. The H2BR performance is the best in case of the throughput-based AGG ABR in figure A. The H2BR average video quality is 12.58 when segment duration is 6 seconds, which is higher than squat and no retransmission by 0.6 and 0.7 respectively. These figures show the average switch step. We can see that our H2BR is able to eliminate large switch steps, which means it provides smoother adaptation behavior. In the figure C, the squat extension even results in more serious switch steps as compared to the original ABR. The figure for squat is 8.3, whereas that of the original SARA ABR is 6.6 when the segment duration is 1 second. If 4-second segments are delivered, these figures for squat is 5, higher than the average switch step of the original SARA ABR by 57%. On the contrary, our proposed H2BR outperforms others if the segment duration is 1, 2, and 6 seconds. Its average switch step is from 10 to 58% smaller than in the original ABR, as shown in Figure C. Finally, the methods are compared regarding the QoE score based on the ITUT QoE model Mode 0. In general, our H2BR scheme performs well in all three ABR algorithms. In Figure A, H2BR improves the QoE score up to 5.8% when the segment duration is 6 seconds, whereas squat increases the QoE score by maximum 3% when the segment duration is 1 second. Our H2BR provides the most significant benefits when the client deploys the SARA ABR and the video segments have 6-second lengths. With the support of our proposed method, the QoE score gains nearly 13% from 3.3 to 3.7. Meanwhile, the figure for squat is lower than the original SARA ABR. In conclusion, our paper proposed an HTTP2-based retransmission technique, namely H2BR, that can work as an extension of ABR algorithms to improve the QoE up to 13%. Besides, a throughput measurement when downloading concurrent segments is introduced in this paper. For the future work, we would like to implement H2BR for streaming scalable encoded videos over HTTP3. That's all of my presentation. Thank you for the attention.